All right, we're going to move on to graphing sine and cosine graphs. And since at this point I can go ahead and assume that you guys know that unit circle well, we'll start filling out this table using that unit circle. So we'll start at the 0. Our sine graph, remember, those are the y values on the unit circle. So 0 is 0. At pi over 2, it is 1. Pi is 0. 3 pi over 2 is -1, and 2 pi is 0. Now, if we went negative pi over 2, that's the same thing as that 270, or this 3 pi over 2, so that's going to be -1, and negative pi would be 0 again. So now we've got some good points. I chose those points on the unit circle because they are whole numbers, so they're a little bit easier to graph. If you did the values in between, so for example, if we had pi over 4, that is root 2 over 2, which is approximately 0.7. And so that's a little bit harder to graph on there, but I do want you to know that these are all the values from the unit circle that you would use to graph every single point on this graph. So we're going to start at the 0, 0 here. There's my first point. Pi over 2 is 1, and I'm going to use these tick marks as 1/2 so that it's easier to show you on here. So this is 1, and this will be -1 there. At pi, we've got 0. At 3 pi over 2, we've got -1. 2 pi, we've got 0. This right here is considered one full cycle of the sine curve. That's also called the period. So this right here is the period of 2 pi. It is one full cycle of that sine curve. From that point forward, it's going to repeat, which is where these values come into play here. So negative pi over 2 is at -1. Negative pi is 0. Our next point over would be negative 3 pi over 2, and that would be a +1. And then negative 2 pi would be 0. And so here is a second cycle of that curve. Notice it's the same thing. It just continues to repeat from that point. So we can keep going. And there's our full picture. As you move into some that are going to be a smaller pi, a smaller period, then you would want to graph at least 3 of them for us. But if you can graph the whole thing, then graph the whole thing. All right, so let's talk about some of the parts of this graph. We did say it repeats and it keeps going forever in this wave type pattern as it goes through. So our domain is from -infinity to infinity. It's going to go all the way to the left, all the way to the right. Now it is repeating from -1 to a +1 on all of these. So all of our values fall between those. So my range would be from -1 to 1. That's the smallest y, biggest y. All right, the period we just said was 2 pi, and that is one full cycle. The amplitude of the sine and cosine graph is from the center to the top of the graph and the center to the bottom of the graph. So in this case, the amplitude is 1. Right on there, center to top or bottom. All right. For our intercepts, there's going to be more than one because this graph starts right here at 0, 0, and then it hits another x-intercept right here at pi, and then it hits another intercept at 2 pi. So every single pi, it's going to be back on the x-axis. So for the first period, we've got 1 at 0, 0. We've got 1 at pi 0, and then we've got 1 at 2 pi 0. You should know, though, that at every single pi, there's going to be another one. So we would have another one at 3 pi, 4 pi, and so on. For our max and min, and we'll just deal with the first cycle again, we've got our first one at pi over 2 and 1. That's going to be our first max. Since one full period puts that point right back in the same exact place, then every 2 pi, we would be back at the top of this graph. Notice 2 pi this way, there it is. Every single 2 pi, you're going to be back at the top of the graph, our max. And then for the min, we've got at 3 pi over 2 and -1. And again, every 2 pi, you'll be back at that -1. All right, so there's our sine graph. We said the amplitude is this part right here. So I'm going to go ahead and label that. There's our full sine graph. We are going to do transformations with them, just like you did with all the functions in the past. This is a good time too to learn what that A and B difference is when we did transformations, because it was harder to see with the algebra 2 functions, but hopefully it'll start really making sense here with the trig functions. Now we're going to look at the cosine. So that's our parent function for sine. Now we're going to look at our parent function for cosine here. Again, you know that unit circle really well, so you should be able to fill out this table quickly. We know that at 0 on the unit circle, our cosine, which is the x values, is a 1. At pi over 2, it is 0. At pi, it is -1. And then 0 and 1 for 3 pi over 2 and 2 pi. If we worked backwards, negative pi over 2 is 0. And negative pi is -1. Again, you could use any of the values from the unit circle, but I am using the ones with whole numbers just because it makes it easier to graph. So we'll use this as 1, and this is -1 again. And so at 0, we are 1. There's our first point. At pi over 2, we're at 0. At pi, we're at -1. 3 pi over 2, we're at 0 again. And 2 pi, we are back up at 1. This is one full cycle of the cosine curve. It starts to repeat after that. So it would go back down over here and back down over here. So it does still look like a wave. I'm going to go ahead and start with that first period so you can see what it looks like. That's what's considered one full cycle of the cosine curve. And it is 2 pi again that one cycle occurs. So as we keep going, we get that same type of wave curve. The difference is, notice that this sine started at 0. So we start the first cycle right here at 0, 0 to 2 pi. And this one, it starts at 0, 1. And then it ends right here up at top again for 2 pi. Those are the points that we would want to start with when we do transformations. So there's our first period. So let's go over this domain. Again, it's from -infinity to infinity. The period here was also 2 pi. For our range, it went from -1 to 1. Our amplitude was 1 again, because from the center to the top, it is 1 unit, and from the center to the bottom, it's 1 unit. That's our amplitude. Our intercepts, we've got our first one here at pi over 2, and then our second one at 3 pi over 2. And again, every single pi after that, just like the sine curve did. So we've got pi over 2, 0. And 3 pi over 2, 0. And again, every pi. Now that was the x-intercepts. In our sine curve, the y-intercept is 0, 0. So it was the same thing as one of my x-intercepts. But for the cosine curve, since it is up, we've got a point at 0, 1 would be the y-intercept, because that's where it's crossing the x, which is where my max is, at 0, 1. And then the min is at pi -1, and those occur every 2 pi, again, since that's the full cycle of the cosine curve that would return it to that same point. All right, so there's my cosine parent function. We've now seen the sine parent function and the cosine parent function, and those are the ones we're going to focus on today. So the next thing we really need to talk about is its transformations. And these are no different than any of the transformations that you dealt with in Algebra 2. So our A, our B, our C, and our D are exactly the same ones as the Algebra 2 functions. Now, C and D, those are the ones that students find easier. So left or right is our C value, and up or down is our D value. Those are the ones that students get really quickly, so we won't spend a lot of time on that. But the A and the B are the ones that were a little bit more tricky. And in Algebra 2, a lot of the times they said the A value and the B value were the same. And yeah, they look the same on the graph, but they don't do the same things. And here you'll see that. So A being greater than 1 is a vertical stretch by A. A being between 0 and 1, and that is the absolute value of A, is going to be a vertical compression by A. I'll go ahead and write the absolute value there so you can see it. Now, when A is negative, it reflects across the x-axis. So there's the A values, and it's no different if it's sine or cosine or any of the ones we dealt with in Algebra 2. So I wrote it over here, but again, they're both the same. Now let's think about this though. If we took that sine curve and we vertically stretched it or compressed it, so that's a vertical stretch right there, then what we're changing is that amplitude. Instead of going 1 unit up from the center, it would go further because we would take it and stretch it. Or we could compress it and then put it closer to that center. So that's what a vertical stretch or compression does. That would not change the period. It would still be all the way to 2 pi. So this A value changes the amplitude. Now let's talk about that B value. And again, it doesn't matter if it's sine or cosine or whichever function you're dealing with. If B is greater than 1, and again in absolute values, then it is a horizontal compression by 1 over B. If B is between 0 and 1, it is a horizontal stretch by 1 over B. And if the B value is negative, then it's a reflection across the Y. So let's go back to that graph and look at it really quickly. If I took this and I squeezed it in for a horizontal compression, or if I stretched it out for a horizontal stretch this way, that is going to change the period. Instead of it starting here and ending here for 1 full cycle, if I'm taking it here and pulling it this way, then 1 full cycle is going to occur in more than 2 pi. Or if I shrunk it in this way, it's going to occur in less than that 2 pi. So that's where now it would still go up this 1 unit from the center because we didn't change it vertically. All we did was the horizontal. So this B value changes the period. Now, since the period for both the cosine and the sine graph is 2 pi, we can say that our new period would be 2 pi over B. So that's going to tell you how many times that cycle happens for both the sine and the cosine. All right, so let's look at some of these. And I'm going to start by showing you the first one on that actual cosine graph, just so that I can show you what that looks like. So we'll start with an easy one here. We could really start on the sine or cosine. But we're going to do y is equal to 2 cosine x with my highlighter. And I'm doing it with my highlighter just so you could see the parent function and see the new one. So this is a vertical stretch by 2. We said that's going to change the amplitude. We're going to take it from the top and the bottom, and we're going to stretch that by 2. So this point that's at 1 would go up to 2. Now this point that's at 0, 0 times 2 is still 0, so it's going to stay right there. This one that's at -1 would go to -2, still at 0, +1, would go to +2, and then we would do the same thing over here. And so our graph now looks like that. That's what that vertical stretch looks like. We still have a full cycle from 0 to 2 pi, but it is going up higher and it's going lower there. That's that vertical stretch by 2. All right. Wanted to show you an amplitude change. Now we're going to go ahead and show you some of the different graphs that you're going to look at just on how to graph it yourself. All right, so we'll start with this example right here. Y is equal to 3 times the sine of x plus 1. We know that this is a vertical stretch by 3 and up 1. So my amplitude is now going to be equal to 3 because that's what that vertical stretch does. We said that changes it there. We also have this up 1 here. So we got to keep that in mind. It does not have a b value, so it is going to keep the same period as my parent function, which is 2 pi. All right, so when we go graph this, with this particular graph, I'm going to want to start with the +1. My center is usually on the x-axis. I'm going to move this up 1. And I'll keep going with what I had on the other side of making this go up by 1. All right, so I've labeled those there so you can see it. So I've drawn this line here just to have as a guide for me. So I just did a broken line there at the 1 for this going up 1. My amplitude is 3, so I know from the center I'm going to go up 1, 2, 3, and so I'll have another dotted line there at the top. And then I'm going to go down 1, 2, 3, and I will have my bottom line here. This makes it a little bit easier to graph because now I have my new center. I know this is going to be the max and this is going to be the min. So I can start with those parent function points. So this is the sine graph. So my parent function points are right here. I was at the center right here at 0, at pi, and at 2 pi. I was at the top at pi over 2 and at the bottom at 3 pi over 2. So I'm going to be at the center at my 0. I'm going to be at the top on my pi over 2, back at the center for pi, at the bottom for 3 pi over 2, and then back at the center for 2 pi. So there's my one cycle for the sine curve. Again, it would repeat that, so I would go back up to the top here, bottom, center, top, center, bottom. And so there would be my new graph. The cycle is still 2 pi. That period is still 2 pi right there. I've got one full cycle in 2 pi. This is my distance of 2 pi right here. My amplitude is 3 because from the center to the bottom, it's 3. From the center to the top, it's 3. All right, let's try another one. For this next one, I'm going to do x plus pi over 4. So in this case, it's on the inside, so I know this is left pi over 4. My amplitude is 2 again. It did not move up or down. So the amplitude is going to be 2 because of this right here. The period didn't change since there's not a b value, so it's still going to be 2 pi. But I'm going to move everything to the left 4. Since it didn't move up or down, the x-axis is my center again. I do the amplitude of 2. Again, since the center is at 0, that's -2 and that's +2. This is going to be my bottom. This is going to be my top. Now, each point is moving to the left pi over 4. So 0, 0 is supposed to be my first point right here. I'm going to move it to the left pi over 4. Now, I think the easiest way to graph from this point is, I know it is a cycle of a period of 2 pi. Sorry about that. A period of 2 pi. So I can go 2 pi to the right, and I know that's where it's going to end. And so with this particular graph here, that's 12 little tick marks is 2 pi. So I can go 12 marks from this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now for the parent function, in the middle of that, it's back at the center. So 1, 2, 3, 4, 5, 6, it's back at the center. And then it goes up in the middle of that. So 1, 2, 3, it's going to be at the top. And then 1, 2, 3, it's going to be at the bottom. And then it repeats from that point. So I can do the same thing as I continue. 1, 2, 3, and I'm back at the top. 1, 2, 3, and I'm at the bottom. Back at the center. Some people think that gets a little tedious as you start going through these, but it's just the repetition of it and getting that graph on there. So remember, for our test, we're expecting you to do at least 3 cycles. If it is the small ones that are really tedious, if it's one of these, then you can get those 2 full cycles on there. All right, so brings us to those that do have a smaller period. So that's what we're going to try now. Here we go. So my amplitude is this 2 from the vertical stretch of 2. the period is going to be affected by this horizontal compression by 1/3. And so we said we take the parent function period, which is 2 pi, and we divide it by that b value. So our period here is 2 pi over 3. That means we're going to have one full cycle within 2 pi over 3. I'm going to start with the amplitude part. So I'm going to have my dotted line up at the top and the bottom. That just makes it easier for me to not even have to think about how far up and how far down it's going. So there is our dotted lines. Now, instead of having one full cycle in that 2 pi, we're going to have one full cycle in this 2 pi over 3. If you know your fractions, that makes it a little bit easier. But here we go. We want this in 2/3 of a pi. Well, here's 1 pi. It is 1, 2, 3, 4, 5, 6 tick marks. So 2/3 of that would be 4. So I'm going to need one full cycle in these 4 tick marks. So I know it starts at 0, 0, and it ends at those 4 tick marks. Now, if you know those parent functions well, then that's where you're going to know when to start and where to end. We know with the sine curve, when it is in the middle of the two, it's back at the center. It starts by going up, so I would be at the top, and then down, I would be at the bottom. So there's one full cycle. That 2/3 of a pi, I have one full cycle there. At that point, it would repeat. And so I would go 1 unit over and keep going on each one of these. Every 4, I should have another full cycle. And so we've got 1, 2, and 3 within that 2 pi, which is what we're doing right here. You can keep going. And you could keep going to the negative side. This is where I say it gets a little bit tedious when there's too many within the graph, because then you're repeating quite a bit. It is a cool graph though. So there is our full one. All right, there you go. There's the sine and cosine graph.